So in this video, we are introducing annuities in this new topic. Now, when we talk about an annuity, this is just a form of investment that involves the regular contribution of money. So if you look at, say, a regular investment here, previously, when we talked about investments and loans, we introduced the compound interest formula or the future value formula. We said that the future value equals the present value times 1 plus the rate to the power of n. Now, when we think of an annuity, this is an agreement between you and the bank. Say you have an investment, you're putting money into an account, it's gaining compound interest, and you want to make regular payments on top of this. We're going to investigate how something like this would work. Now, let's say you wanted to invest $1,000 into an account at the end of each year. So at the end of each year for 4 years. And the rate is 10% per annum, compound interest. So let's just explore how something like this would work. You would have the compound interest, so you would have money in this investment and it would naturally grow, but we're going to see how this would look when you're making extra repayments on top of this. So at the end of your first year, you would have basically, right at the start of the account, you open the account with no money, right? So we would have basically your future value would equal the thing you start off with. So you start off with 0 times 1 plus the rate, which is 0.1 to the power of 1, because it's for 1 year and it's compounded annually. And we add 1,000 at the end of the year. So at the end of the year, we're making a payment of $1,000. That means that we would get, at the end of the first year, we would have $1,000 in our account. Okay, sweet. At the end of the second year, so we have end of second year. What's going to happen is we have our future value formula. Remember, we are taking a present value, 1 plus r to the power of n, but we're adding 1,000 at the end of it, okay? So this means that our future value is going to be 1,000, our present value, because at the moment, our present value is here. This is what we've sort of gotten at the end of the first year. So the end of my first year becomes a present value at the end of my second year. So I get that times 1 plus 0.1 to the power of n, to the power of 1, I should say. And then what separates annuities from just a regular investment and letting this grow on its own is we're making the extra repayment at the end. We are trying to basically like beef this account up a little bit. So this is going to give me 2,100. And this is going to basically continue on like this. So we have at the end of the second year, end of third year, sorry, our future value is we are taking my 2,100, we're multiplying it by 1 plus the rate to the power of 1 again, and then we're adding 1,000 again. So now this bumps it up to 3,310. So essentially our money is growing because we're making, and it's growing more because we're making these added contributions. That's what separates annuities from what we were doing back in investments and loans. Now, this is one example for an investment. Another example would be for a loan. So say you take out a loan, you have, 1,000 to pay back. So let's say a loan of $1,000 at the rate of, let's say 10% again. And let's go compounded yearly. yearly, and making yearly repayments. I'm just keeping it in years just to make it easier so we don't have to worry about different compounding periods. Yearly repayments of, I don't know, $250. I'm just picking really small, easy numbers to work with. How that would work is instead of adding now, you're starting with $1,000. So you have this $1,000 that you owe, and interest is getting charged on this, right? Because anytime you take out a loan, how the bank makes money is they charge you interest. So for something like this, it would be 1,000 times 1 plus 0.1 to the power 1. But at the end of that year, because we start off with $1,000, we're not starting with zero and working our way up like we would with an investment. We're starting with an amount, we're charging interest on it, and then we're taking away our repayment. So how this differs, if you consider these two, let's say this one over here and this one down here, instead of adding, it's taking away because we're trying to reduce the amount of the loan. So this part here in our formula, that is our interest. So we're sort of charging interest on that. So we're taking our future value formula, and this part is our repayment. And the same thing happened up here, right? So with our investment, we calculated our interest, but instead we added an extra repayment. So how these two differ, with our investments, we are adding the repayment at the end because we're trying to get more and more and more and more money. With our loans, we're kind of taking out a loan on some amount. Interest is getting charged at a particular period. This could be monthly, yearly, weekly, daily. And we are making a repayment. Instead, not to increase the value, we're trying to reduce the value of the loan. So the repayment we're making is taking away. So we charge interest on this, then we minus the repayment. So that means there's less we have to pay. But it's kind of a balancing act, right? Because we're getting charged interest, so that's increasing the value we have to pay, but then we make the repayment, which lowers it down a little bit. And then we keep going in this way until the loan is paid off. Here, we just keep going up, we increase our money until we reach a certain amount we want, or until we want to stop this from happening. Now, we're going to investigate this and formally give a formula to this in the next video and continue to explore that. But that brings us to the end of the video today. Thank you so much for watching, and I'll see you next time.